Hi everyone, so this video we will talk about the product rule and quotient rule and some higher order of derivative. So for the product rule, let's look at an example first. If I have the derivative of x squared times x cubed, do you think that this gonna equal to derivative of x squared times the derivative of x cubed? Let's see, let's check. On the left-hand side, I have derivative of x squared times x cubed. When you have the x squared times x cubed, it means you're going to have x to the power fifth, right? Because x to the power m times x to the power n is going to be x to the power m plus n. So we add the power, so we have x to the power fifth. And what is the derivative of x to the power fifth? Based on the power rule, we're going to bring down the power, which is n, and then x to the power n minus 1. So we're going to have derivative x to the power 5 would be 5 times x to the power 5 minus 1, which is x to the power 4. All right, so on the left-hand side, I have the derivative of x squared times x cubed to be 5x to the power 4. Now on the right-hand side, if I take the derivative individually and multiply them, I will have 2 times x to the power 2 minus 1. And 2 times x to the power 2 minus 1 is 2 times x to the power 1. On the d over df of x cubed will be 3 times x to the power 3 minus 1, which is 3x to the power 2. Now we multiply it again, we have 6x to the power 3. And isn't that does not equal to 5x to the power 4? This does not equal. So the derivative of product cannot be the product of derivative. So that turned out the product rule gonna be something like this. Okay, so actually the product rule of two different functions, the derivative of the product of two different functions is actually will equal to the derivative of the first function times the second function plus the derivative of the second function times the first function. Or some of the people may think, you can use one of the phrase that is make easier for the derivative process of the product, which is you consider this is the high function and this is the low function. Then your derivative will be low, stay the same, times the derivative of high, low d high, plus high, stay the same, times d low. D low. Okay. So let's use this phrase to apply to the problem down here. I know for this problem, you don't even need to apply the product rule, but I would like you to use a product rule for this just to get used to how to use the product rule. So let's find the derivative of this, and I call this going to be my high function, and this going to be my low function. So derivative of that will be low, which is 1 over x minus 1. D high, which is d over dx of x squared, plus high, which is x squared, times d low, which is d over dx of x to the power negative 1 minus 1. So when I take derivative, it's better to bring up the denominator and make it become x to the power negative 1, unless you are already get used to with finding the derivative of 1 over x, okay? Now I start taking my derivative. So 1 over x minus 1 stay the same. And derivative of x squared is a power rule. So we bring down the exponent. We have 2 times x to the power 2 minus 1, which is 1. And then plus x squared stay the same times derivative of x to the power negative 1. We're going to do negative 1 times x to the power negative 1 minus 1. Negative 1 minus 1, which is negative 2. And then derivative of constant is 0, right? Derivative of constant is 0. Recall that. Constant 1 is 0. So that means you only have the derivative of x to the power -1 minus 1 is -1, x to the power -2. And then now we're going to simplify. So x to the power 1, I don't need to write a 1. I can remove it. And then I'm going to distribute the 2x to 1 over x, which is 2x times 1 over x minus 2x plus, because of the negative right here, I will have subtract x squared times x to the power -2. So look like I can cancel out the x. We have 2 minus 2x minus x to the power 2 times x to the power -2 is x to the power 2 minus 2, which is x to the power 0, and that is 1. So it's going to be 1. And 2 minus 1 is 1 minus 2x. Okay, so this is pretty much, this is how the product rule look like. But for this problem, you don't really need to do power rule. We can actually distribute the x squared and then take the derivative individual term. You will still get out with the same result, okay? But I do want you to apply the power rule for the problem just to get used to